This is Amanda Bernard. Amanda is our head of product design at Honeycomb, and she thinks AI is the most exciting innovation for design since she started. That's saying something because as a product designer, she has reasons to be hesitant. At Honeycomb, we care a great deal about our user interface. Honeycomb is an observability platform, so we take in a whole slew of production data from applications about what the heck they're doing, and we make that comprehensible to people. This is challenging, which is why we hire great designers like Amanda. But AI, and in particular MCP, ignores our carefully designed product UI. Yet Amanda is excited about MCP because it lets us bring that sweet production data to right where people already are. And that's why MCP is an MVP. For instance, it brings Honeycomb into Claude Desktop, where it can answer questions for our salespeople, like, hey, I've got this account I'm working. How many people from that account have used Honeycomb in the past month? Claude can do that using our MCP. Or in an IDE, developers can let the agent correlate what's happening in production through Honeycomb with the code that it already has access to. And that closes a feedback loop of develop, deploy, operate, and production should influence development. That's core to Honeycomb's mission. So MCP is important, but what is it? MCP stands for Model Context Protocol. Now, model is really more about agents or AI applications, which talk to a model. And through these MCPs, bring to that model context about the real present world. And then the protocol part is important because any AI application can use MCP servers, and any service or person can implement an MCP service to supply new context. So it looks kind of like this. The AI application or agent is mediating between the user, any MCPs or other tools, and the LLM model. So that application might be Claude.ai, ChatGPT, eventually, or Claude Desktop. And you can connect to multiple MCPs and other integrations. And then I can do things like say, hey, what should I work on next? Check my calendar and my tasks and see whether anything is blowing up in production. And Claude can do that for me. Or this could be in an IDE. It could be Copilot or Claude Code. And we can connect to Playwright to run browser tests and Honeycomb to check production. And I can ask things like, hey, check Honeycomb to see which endpoint is the slowest, and then take me to that code. And then Claude or the other agents, they can do that right there where I already am. Another one we really like is the Figma MCP. So Figma is where Amanda and her team create all those fancy product designs. And the MCP hooks those product designs up to the agent and gives the agent exactly what it needs. The variables for each color, the pixel numbers between different things. Beats the heck out of pasting in a screenshot and hoping it can interpret that. All right, so when we hook all these together, you might look at this picture and say, oh, so it's an API, right? It hooks software together. No. Because our software API, of course, we have that, and it's very specific and very rigid because you need this to not change. That deterministic software that's calling the Honeycomb API is going to send the same thing every time and expects the same results in the same format all the time. And if you want to change that, there's documentation, it has to go through people. It's a lot of work. MCP is different. Our descriptions and responses that the MCP sends are interpreted by an LLM, and that LLM has no memory of what our MCP responded with yesterday. It does not care how often that changes. And that's a whole new world of flexibility. So you might look at this and see it sending text back and being like, oh, so it's a textual UI then. Well, no, because at least it's not anything like a CLI that humans would use. Because humans, like expect the same thing back from day to day. They also expect the software to do exactly what they ask for predictably. And we have more flexibility than that with the MCP. Now, you can look at it as a user interface if you think of the users as the different models. So ChatGPT 4 and 5 and Claude Sonnet and Haiku and Opus and Olama, these are our users. They need to be able to understand the MCP's output. And they're willing to sit with you all day long and user test your software and give you their maybe 2 complimentary opinions. So you can change it whenever and test it whenever, because MCP is its own living documentation. Now, I'll show you what I mean by that. Let's look at the protocol at a very high level. When the AI application is going to connect to an MCP server, it does this by spinning up an MCP client. Now, that client can be a modular process, whatever. It's deterministic software, which can be tested and has the possibility of being secure, which is important because it's going to do things like authentication. Pop open a browser window so I can go through the OAuth dance, and then as a user, I can log into Honeycomb and authorize the agent to act on my behalf. And then that authentication data is safe. Okay, so then the MCP client is like, yo, what you got for me? And the server's like, oh, I got some prompts and some tools. There's some other things, but tools are what matter. Tools are the fingers that the MCP gives to the agent in the world. Also, we provide it with some instructions, and those instructions are text to be interpreted by the LLM. So when you use our MCP, you want to get workspace context and then some data sets and some columns and then run queries. And after that, the MCP client says, okay, you said you had some tools, tell me about them. And then the server responds with complete definitions of each tool. Sometimes that's a lot of tools. I'm looking at you, Asana. These are all the tools that Asana offers. Clearly, they just wrapped their API. Okay, to be fair, we did that first, but we've since improved it. A hot tip, if you configure something like Asana right now that offers way too many tools, turn most of them off. And that's because all of the tools that are enabled are going to provide definitions, and those definitions are going to get into the LLM's context. And that context window is limited, but more importantly, the more irrelevant stuff you put into that context, the less well it can respond to what the user asked. So here's an example of a tool definition. It's JSON. It's got a name and a description and the parameters and all their descriptions and what the valid values are. It gets to be a lot of tokens, so fewer tools are better. After the agent retrieves all that from the MCP server, it sends the prompts along with a tiny bit of the user's text and also all of the MCP instructions and the list of tools over to the model, which responds with, well, I think the thing that comes next is these tool calls in JSON, the ones of those that are for the Honeycomb MCP. We then get, and we can respond with any kind of text, including but not limited to JSON, which then gets sent to the LLM along with the entire conversation history, because that's how that works. For instance, if the LLM says to run a query, get a count and a heat map, then we respond with ASCII art. Seriously, I copied this out of one of our responses. We tried JSON. It took up a ton of tokens and wasn't super communicative. I mean, I agree. I don't find JSON terribly communicative. This is much more communicative. And apparently the models feel that way too. They can work with this. It's amazing. As another example, if the model says, let's get a trace, then it's asking for a bunch of spans in one distributed trace describing a request, and we give it some of what it asked for, but not the whole thing. Instead, our MCP server applies some interpretation. It says, oh, look, this is a long trace. I know what a long trace is. I'm going to tell you, there's 8,000 spans in here. And what you probably want to do is investigate the slowest one. Here's its ID. Use this tool call to investigate that. And then some other advice. And then at the bottom, there's some CSV here, which is a little more efficient than JSON. And we give it some of the spans, but not everything. This is what I mean by the MCP is its own living documentation, because it is telling the model what it probably wants to do next. We're not just supplying data, we're supplying expertise. And we can be bossy. We can tell it what to do in a way that would be rude to a human. So the MCP is really a third interface. It is not a software or a human UI. It's its own thing. And as such, we have new design principles to find and lots of opportunity to find them because we can iterate and learn from it quickly. Those feedback loops are what matter. So we've noticed that you want to have fewer tools, you want to conserve the context. The fewer tokens in the context, the smarter the LLM. And we're always looking both at our evaluations, more on that later, and at what happens in production, because it's really all about that feedback loop. For instance, we can look at the errors that our MCP is sending back in response to some tool calls. And here's one that we got a lot of for a while. This is a terrible error message. I mean, look at it. It's like, invalid parameters. Look at your times. Look at your operations. No. If I'm Honeycomb, I know what operations I want, not you. I need to tell you what to do next. So for example, here's a better error message that we send more recently. This one's great. It says, hey, you sent the same column name in these two places, and that doesn't make sense because this, and here's some useful knowledge about Honeycomb and observability, and here's what you might want to do differently. That progresses the conversation. Or here's another one that we got a whole lot. Oh, you sent us count with a column name. Count doesn't take an argument. It's just count. But it happened so much that we were like, well, what if? And we looked, and our data store actually supports counting only the rows with a value in this column. We just never exposed it in the UI. Well, this is a UI we can change. So we added that functionality to the MCP. And on July 28th, those errors end. And a few weeks later, after going through changelog and docs and all the overhead of telling humans about it, we put it in the product too. So MCP has improved our product. The errors in tool calls are informative, and they're not failures. They're just part of the process. Because what we want to test, what we want to succeed at, is not just one tool call. It's this whole interaction with the application and the model and the MCP. Are these able to solve the user's problem? That's success. And it doesn't matter how many tool calls failed if it eventually got to the right one. So that's where evaluations come in. And we evaluate the system as a whole, pick a model, pick an application, an agent, hook up the MCP with some known data, give it a prompt it ought to be able to respond to, and see whether it does. We use a different LLM to judge the result. And we track pass-fail, number of tokens used, how long it took in the wall time, and how many different tool calls. And this gives us an idea of progress over time. Are we getting better at communicating to these models? This is a trace of one of our evaluation runs. We try 5 or 6 prompts. We judge them at the end. We can run this for different agents and models. So far, we do this nightly. And then, of course, we look at production data. Are we throwing HTTP errors? Those would be bad. And what error messages are we getting? Who's using it? Who's using what? These evaluations are crucial, because if they were good enough, we wouldn't have to write the software. The AI could do it for us. We are not there yet. But MCP is a joy because it is so flexible, because it brings this data right to where people already are, because we get to be bossy, which is a new taste to develop, and because the feedback loops are so fast. I love it. This quote again, AI and MCP are great innovations in design, and therefore, we need to innovate in how we design with them.